Hello, my name is Aiden Kurtek, and today we're going to be finding volume using calculus. Specifically, we're going to be finding volume by rotating an object around the x-axis. There's many ways to do this, but I feel like this is the most common way to see that it will be seen. To find this, we're going to need two things: our x-bounds and our radius. X-bounds will tell us from where we need to integrate so we can properly spin everything around. And the radius is going to be telling us, so give us the formula for our area so that we can add up all the circles, which is going to be our goal of this. To understand this, it would be beneficial to have understanding in graphing algebra 1 and understanding how to integrate. This isn't necessary, but it will help a lot. I'm going to go through the problem to finding the volume of y equals 4 minus x squared and the x-axis rotated about the x-axis. So the first step is to graph this on an xy coordinate chart. So we're going to put in here y equals 4 minus x squared and our other equation, which you guys might know, since the x-axis is really y equals 0. Then the next step is going to be drawing a rotator. This will help us a lot, especially in more complex problems. It might not always be just on the x-axis. So we're going to be drawing in lines perpendicular to the x-axis, actually perpendicular to our rotator specifically. And I'm going to draw one box here just to help me visualize what we're going to be spinning around and calculating the volume of. Now that we have like a basic shape of what we're going to be doing, I'm going to quickly draw a 3D shape of the thing. Alright, so this kind of looks like an M&M, kind of, or like two contact lenses poked together. Alright, this is everything we needed to do for this step, so we're going to be moving on to finding the x-bounds in the shape. As you might have seen it there, it was -2 and 2. Sometimes you're not going to be able to graph it as precisely as this if you're just doing it by hand. So one way to do that is set the two equations equal to each other. So 0 equals 4 minus x squared. Then solve for the x, which would be x equals plus or minus 2. And these numbers are going to be heavily used later in the process. An integral in the context of finding volume is just adding up all the small areas together. An integral function adds up everything. So like I said before, we're going to be adding up the areas to, if you add up enough like small bands of the areas, that small square rectangle I was drawing, if you add up all of those together, you'll get a volume. So that moves us on to our next step, which is finding the radius. Handy for us, this problem is pretty easy to do that. We're just taking top minus bottom, so we just have our top function left. So it's just 4 minus x squared. And how many of you guys know the circle area formula? I know. It's pi r squared. And we just found our radius, so we just plugged the radius right in for that. Now we're going to be moving on to integrating that. Which integrating that is pretty simple. So we just draw our integration sign from our x bounds, which is -2 and 2. And since pi is just a constant, one rule for integrals is you can just swing constants out front. This makes life easier for future steps. Integral is undoing a derivative mathematically, and a derivative is the slope at it finds you the slope at any point, basically. Or that's what the first derivative does. Tell us if a graph is increasing or decreasing, really. All right. So we have r squared, which is 4 minus x squared quantity squared dx. dx is the little sections that we're going to be adding up together to get our whole thing. So we're going to quickly FOIL that out. I'm just bringing down the integration. I should probably put volume equals. Then we have 16 minus 4 times negative x squared, which is negative 4x squared. And then we have two of those, so that we have negative 8x squared. And we have positive x to the fourth, all times dx. Now, here's the kind of tricky step. This is actual integration. So we're going to be we're reversing a derivative. So derivative will give you the slope of something. So y equals x is a straight line and a constant slope. So that would be x of 1 as a derivative. So you're basically finding the number before just a singular x. So we have 16x, which is, we're undoing that process, so we're getting back to the slopes. 16x minus 8x cubed, because we're adding up 1, if you haven't noticed that. And we're putting it over that number. That's a quick shortcut to do this. Because if you had like x squared, it's increasing quicker, so the slope would be 2x. Something just to keep in the back of your mind. Then this would be x to the fifth over 5 by the same logic. We're going to evaluate this at negative 2 and positive 2. That's what the bounds are for. So that's a little bit. All right, we have equal to pi times higher bound 16. Because this is a parabola and each sides are symmetric, we can just do 2 times. This is going to save on a little bit, and we're just going to ignore the bottom one. We're going to say it's a 0. It just saves on a little bit of time. So we have 32 minus x cubed, which is x cubed times 2. No, 2 cubed. 8 times 8, 64 over 3. So that's 21 and a third. We have plus 2 times 2 times 2 to the fifth, which is really just saying 4 times 4, 16 times another 2, 32. 32 over 5. So that's plus sorry, plus 6 and 2/5. 32 subtracted by that. So what is the answer we're going to get? We're going to get 32 minus 21 and a third should be 10 and 2/3 plus 6 and 2/5, which should give us, all right, so this is basic fraction stuff. So 5 times 2, which is 10, and 3 times 2, which is 6. So that'll give us 17 and a 1/15th. Yep, 1/15th. And then we're going to be multiplying this by 2 times pi. So that'll give us our final answer. The volume of this shape is 34 and 2/15ths pi cubic units squared. Units cubed. If you want to try one of these problems on your own, here it is. Please write and see what you think the answer is.